hopefully you should see that.
Right.
So I want to talk to you about storage spaces. In general, we're going to start with a little bit of the basics of distributed computing. Not everyone is familiar with distributed computing. Some of you are maybe experts in that. So you may not need to pay attention to this, but we're starting from the idea that, we're going to try and start from the start and give an introduction. So what are the types and roles of DUNE's data volumes? What are the commands and tools that you can use to access that data, find out the locations of that data that may be distributed all over the world? And the reason this is important is that we have DUNE data distributed on disks and on tape all over the world. It is not necessarily easy for you to access that. But then there are also disks that you will be using that are available to you that are not accessible except on the interactive node that you've got. And understanding the difference between those and how to get data or scripts or software from one onto the other, and then to be able to use it on the greater Open Science Grid or the worldwide LHC computing grid, that is important. So, okay, so in general, there are three different types of storage that you are going to encounter at Fermilab or at CERN, either one. They are going to be a local hard drive that is literally physically in the server that you are logged into. Acts the same way as a hard drive that's inside of your laptop. There are going to be network attached storage, which is something that is connected over an Ethernet, and it functionally appears as though it is a local hard drive, but it is not. In fact, there's packets going back and forth across an Ethernet cable somewhere or a Wi-Fi router. And then the last thing is large scale distributed storage. And that is stuff that is, if you will, if you think about things that are out there in different countries, in different cantons or states or whatever, that you have to access through very specific protocols, your laptop is not going to be aware of that. The interactive node is not necessarily going to be aware of it. You can't list it, but you can use special protocols to access it. A little bit of vocabulary. Does anybody know what POSIX is or has heard of it? One person has heard of POSIX. So POSIX is a standard of how you interact with a storage element. And it says, okay, in order to, when I talk to a disk drive, I need to be able to run a bunch of commands and access it with a given set of protocols. So when you do like ls in Linux to list a directory, or if you do a make directory or you delete something, or if you want to modify something, all of those processes are POSIX compliant in general on your laptop and a local hard drive. That is important because when I talk about large scale distributed storage, it is not POSIX compliant. You shouldn't think about accessing those large scale storage elements the same way that you think about accessing a hard drive on your laptop or on an interactive server. And as well, there are times in which network attached storage, you also should distinguish what kind of access I'm going to have, because again, you're going across an Ethernet cable. You're not going through an IDE port or something like that. Grid accessible. This is the thing. If in general, if it's grid accessible,
it's better if you use the mouse.
It's better if I use the mouse. Okay.
Because then people remotely can see what you're pointing.
Sure. Okay. So what is it meant by grid accessible? That's what I'm talking about. So volumes that are grid accessible, we've got special protocols and tool suites to handle the data stored there, get that information back to you. Immutable, in general, on grid accessible or these large distributed storage, files are immutable, meaning once you put a file there, you really kind of can't change it. You can't edit it in real time. You can't open it up in VI or root and change it. It is static. If you want to change it, you download it, you modify it locally, you delete it on the remote system, and then you send it back up there. But you have to be thinking in your head, what am I accessing? Because can I actually edit something that is, on a storage element that is in the Netherlands? No, in general, you can't. You have to copy it over, modify it, delete the remote copy, and then send it back. So
enlarge the string alone so that it's more readable.
Sure, I can do that.
Because like a control plus.
Yes.
Well,
no, not that.
Heidi, I'm trying. This mouse is incredibly laggy.
Yeah,
so
because what you're seeing is the Zoom session. if you turn around and face the screen while you move the mouse,
That is live.
yes.
Wow,
then
okay,
it's
that's
live.
fantastic.
Yeah,
Okay.
so do a Control Plus,
Right.
just to make it bigger. Sorry to interrupt, but
That's okay.
I'm a real
There we go.
thought about font sizes.
Yeah.
Yeah, okay, good.
So, interactive storage volumes. Okay, so I'm going to talk specifically about DUNE GPVM, but in general, this applies to LX Plus. So, is anybody here only have CERN accounts and not familiar with LX Plus? You don't know what LX Plus is. So, LX Plus is the interactive set of servers that are provided by CERN IT. Basically, you log in to a round robin. It puts you on one of them, and then all of a sudden you have you're logged into a Linux machine that's here at CERN and has that information. It is going to be literally LXPLUS, a couple of numbers, .cern.ch. But at Fermilab, you're going to be logging into DUNE GPVM xx.fnal.gov. So those are those nodes.
Where XS is 1 through 15.
Yeah, XX is 1 through 15. If you care, GPVM stands for General Purpose Virtual Machine. But just if you're curious. Anyways, okay. So either place, you have a home area. This is really similar to your local hard drive on your laptop or your desktop machine, right? It is network mounted. That's the interesting thing. At Fermilab, you have the same home area for any experiment you're on, any node that you log into, they are all replicated all the way across. Access speed to this volume is really high. It's got full POSIX access. Again, their network volumes, they're not safe to store certificates or passwords or any of those things, right? They are going out across the Ethernet, so you don't generate a Kerberos ticket or a proxy and then put it in your home area. There are locally mounted volumes where you can do this. All of that is saved there automatically, unless you specify something strange. Anyways, you have a single home area at Fermilab. I believe the same is true for CERN. It is not accessible from grid worker nodes. Also, they're really small. They're only like 2 gigabytes. That's all it is. The idea is you have some init scripts there. You have, .bashrc or TCSH RC. You do need a valid Kerberos ticket to access it in your home area. So if you don't forward your ticket, you're not going to be able to access your home area. There are periodic snapshots. So if you do an RM-RF,
Don't do that.
anybody know what anyone not know what RM-RF is? Cool, that's great. Don't do it. But, anyways, it happened to a CMS user yesterday, and I got to hear about it. Anyways, the great thing is there are snapshots. You can go to NAS home snapshots. What? Only the home area is what I'm talking about right now.
Okay.
There's a snapshot at Fermilab. That is what they're doing. So you can go back and recover. Don't test the system. Don't try and find out how long it lasts there, because I won't promise you that it'll be there or that it will have been a snapshot of the latest edit. Locally mounted volumes in general, these are like /var/temp. They're mounted on the machine through a motherboard, not over the network. This is the only place to put certificates and tickets. That's really all that they're there for.
And by default, they are put there anyway when you use commands or 8.
Yep, exactly. As I note in the 4th bullet, they're automatically saved there, photo read enabled, and other permissions disabled. So if you don't do anything interesting, you don't put in an option to your Kerberos init command, it'll go there and you're good, you're safe. The last thing is network attached storage. It basically functions the same way as Dropbox or OneDrive or whatever you use that, where you keep your photos in the cloud. It's fast, stable POSIX access to these volumes. They are available only on a limited number of computers and servers. So LX Plus has some network attached storage. Great, no problem. DUNE GPVMs have network attached storage. Those volumes are not out on the grid. So if you write a script to generate some Monte Carlo and you then submit it out to the grid and it is trying to access one of these network attached storage drives where you've got your software, it's not going to work. Right. So that's the thing that you need to think about, is that I can develop my software there interactively. I can compile it. But if I want to get that out onto a grid worker node, I've got to do something to get it out there. There is At Fermilab, you have /DUNE/app. Sorry, I'm not using the mouse. I like to stand up as opposed to sit down. But anyways, we have DUNE app right here, and then that does have snapshots, which is great. So if you mess things up, you go to DUNE app.snapshot and look and see, try and recover if anything got deleted. The data do not. So there are two network attached storage volumes. They don't have any snapshots or backup. They are much larger. And that's why they don't have snapshots, because we just can't afford that much disk. So we want to give you more space because you're putting data there, but like all of your code development can be done either place. But if you want to have a snapshot, you should do it on DUNE app. Questions?
Everybody keep up so far?
I have a quick question.
Yeah.
Yeah, use the mic.
Here's your mic. You turn on your mic.
There we go. I pressed the button too many times. So I look at my home directory, and it's NAS home, but then I also can look at LS DUNE app users and my username, and it's the same place. Are they logically connected?
Nope.
There is DUNE app users and your username. That is a space that exists. They are not logically connected, other than it just happens they're using your username as the top directory, and ownership is the same, but they are two completely separate volumes, and it's effectively two different hard drives. In fact, it is definitively two physically different hard drives located in different racks in different places. So both of them are network attached storage, but they are coming from, one is in one building, one's in another building, or at least think about it that way. Okay, so grid accessible storage volumes. There are a bunch of different technology solutions you may have heard of: Dcache, EOS, Ceph, what have you. And at Fermilab, we have Dcache and NStore. At CERN, it is EOS. The idea is these are big volumes that you can put lots of data, and then you can access them from thousands of nodes all at the same time and not have access problems. If you try to access the network attached storage from 1,000 different worker nodes spread out, or 10,000 worker nodes spread out across the world, you would have serious problems. They are not designed to do that. Whereas the grid accessible ones are designed to do that, be robust, hold up against all of that demand. But that also means that you can't directly access them. You can't necessarily just have them mounted on your laptop or on an interactive node. Three different types. There at Fermilab, there's persistent Dcache. Basically, it acts just like a hard drive. You write a file to there, it stays there, it doesn't go anywhere. There is stash cache. Scratch Dcache. This is a really large volume. I think it's like 6 petabytes of data, something, or volumes of disk right now. But the thing is that in order to write a file, it deletes a file. And the files that get deleted are deleted upon a least recently utilized policy. So if you haven't touched a file in a month or 2 months, guess what? It is the first one to go out the door. And it is not based on your files, it's based upon all files, and it's shared across all experiments at Fermilab. This is a thing to think about, and now like churn in your head for a little while, because if another experiment, Fermilab, suddenly starts to write 3 petabytes of data, they're going to flush everybody else's files out. Or if you do the same to another do the same and write 3 petabytes of data, good on you. We want you to work for us, because that's impressive to get that kind of thing. But also, you will probably upset every other experiment at Fermilab, because you will just flush 3 petabytes of data off of the scratch space. It's good, it's bad. You can never fail. You can never fill up the scratch space. But what you can do is you can flush everything out into the bit bucket, and then you never get it back. It's gone. Last type is tape back Dcache. What this is it's a disk that sits in front of a huge tape library. You write a file there, it copies it to tape. It goes into archival storage. It then stays on that tape until it is deleted. In general, that's not going to happen unless you have the controls of Ruscio, you're in the data management team. But in general, it will stay there There's a really cool video of the tape storage robot that you should click on at some point. The other thing to think about is you write the file to the disk, it gets copied to tape. That doesn't mean that it stays on the disk, right? That disk is just a staging area, and that staging area gets churned over, again, same as the scratch space, and eventually the file goes off of disk. It's now in a tape, but the problem is that tape is not live. It's filed away literally in a library. And so to get it back, you've got to ask, please copy it off of the tape, put it on disk. Now I can get it from disk. So there is a delay. And that delay can be anywhere from 12 hours to 2 weeks. I'm not going to cover resilient. So there's a nice table, persistent, decache. I haven't distinguished the difference between the top two. One is just a general usage. Anybody can go there. It's great. It's about 100 terabytes.
No more.
It's okay.
350.
Oh, sorry.
350 now.
It's 350.
Not terabytes, petabytes.
No, terabytes.
Terabytes. If
Yeah.
we had 350 petabytes of disk,
Oh,
trust me,
okay.
I would just quit because there wouldn't be problems for a decade.
Right.
Yeah,
Yeah.
that's
Awesome.
right.
And if you use too much, we come and find you when
Yeah.
you're down.
There is a persistent area from the physics groups. So every one of the physics groups coordinators has been given access and control of that disk. Basically, if you want to write to it, you've got to go talk to the physics group. They each have something on the order of, is it
50?
50 they have 50 terabytes. So you can put common samples there. Anybody can read from any of this, but you can't necessarily write to it unless you've gotten the permission of the physics group. So there are quotas on that. I think I've said everything in this table, but the nice thing is, this is a good reference. What are the lifetimes? Is it tape back? Meaning, are the files going to be there for forever? What is the use, right? You've got, immutable files with long lifetime in the persistent area, immutable files with short lifetime in decache, long-term archive, and then the data and app volumes being analysis samples, storing and compiling of software, and then storing global environment scripts. So all of this setup DUNE.sh that you saw and you did in the prereq, all of that goes in your home area because it's tiny, right? And it works pretty great. Questions before we move on to examples? And I check the time. Okay, I'm a little bit over, but okay. So there's a really great diagram that is complicated.
You move around. Sometimes you cannot hear you from. Yeah, if you can just wear this one, and
Yep.
you can move freely around.
Yep.
So for this,
No, that's fine. Thank you very much for the assistant. I appreciate it. And apologies to those on Zoom who weren't able to hear me earlier. Yep. Okay, it's a nice diagram. So real quick, I want to say, words of wisdom. Remember, these volumes are not infinite. Monitoring your and the experiment usage of these volumes is important to smooth access to data and simulation samples. There's a link to look at your persistent usage here. Again, that's Fermilab only. I think it requires a single sign-on to get access to it. Ruscio manages our global storage elements, the ones that are distributed around the world. If you really want to dig into that, go for it. But mostly just an example of how much data we have. We have petabytes of data. It is difficult to access them in the sense of, I don't know where to look for something. So we have developed tools that will help you with that. So what are some of the command and tools that we've got that will help you out? Primarily IFDH. Ooh, there's an echo. IFDH.
If somebody, whoever's got Zoom going, you need to mute.
Yeah.
And turn off your.
That's okay. So IFDH, Intensity Frontier Data Handling. This is a little software toolkit that's existed for a pretty long time. It was developed for the Intensity Frontier, go DUNE, and all of the smaller experiments. Hopefully you have gone through the mission setup, and issuing all of these commands would be a cut and paste for you. But let me talk to you a little bit about what's going on. we set up our environment. We then set up the DUNE software system and the DUNE specific software environment. Do a KX509. We're going to generate a Kerberos ticket for ourselves. But then the next thing that we need to do is we need to generate a proxy. The difference between your Kerberos ticket and a proxy is a little bit of the information that it is included, what it gives you access to, and what its lifetime is. Here, we have said that we want to be in the analysis role. We want it to be valid for, I can't remember, I think that's 120 minutes. So for about 2 hours. And then there are a couple other flags in there. At that point, the great thing is we've got a thing that we can use to go and access all of the data. And the first thing that we are going to do is we are going to copy a proto-DUNE reconstruction file that is simulation, and we're going to copy it to DevNull. Does everybody know what DevNull is? Who doesn't know what DevNull is? Yeah, okay, awesome. Thank you for raising your hands. DevNull is one of the great places on a Linux operating system. It is an infinite sinkhole. You can copy things there and then they just disappear. But the great thing is that you can test out whether or not I can read something and I can write it someplace. The great thing is you never have to clean up DevNull because it literally just goes into the trash can and disappears. So if you want to test whether or not you can read a file, but you don't want to have to go and clean up the file and delete it later, copy it to DevNull and it just goes away. So, or if you don't want to pay attention to any of the warnings of compiling, pipe all of your output into DevNull. And then you don't have to worry about unused variables. That is a really bad idea. That is a horrible idea. I genuinely please don't do that. So,
Turn off all the warning messages in your compiler.
Exactly. That's right. That's much better. So hopefully everyone can log into either the DUNE GPVMs or LX Plus, and then issue these kind of cut and paste what looks like 7 command lines and see what happens.
If you're in LX Plus, you're going to have problems with KX509.
Oh, okay.
It's not working out of the box. I'm trying to figure out why.
I apologize for those that only have certain
It used to
access.
work.
So. To talk specifically about what's going on with the IFDH command, if you look right here, it's just IFDH, Intensity Frontier Data Handling, copy your input destination, which is an xroot. This is called an xroot URL, and then a destination right here. The biggest trick with this command, if you want to copy to a directory, you have to give it the -D option on the command line.
Okay, KX509 will work on CERN, but only if you have a Fermi-Love Kerberos principle, otherwise not.
Oh,
We've broken it.
yeah, we've broken it. I'm sorry.
But it should still be possible to get a Vamos proxy even without that. It'll give you a way.
Okay,
Okay, so put it in the.
and then we'll update the instructions.
Yeah.
Okay, so
Dang.
the first exercise that we want to do is this. I just showed you the answers. Oh man, that's no good. Okay, so the great thing is that we have these huge volume, these huge storage elements that we've got that have petabytes of storage on them. If you use IFDH, you can do things on them the way that you would normally do things on your laptop, but you need to use the IFDH client in order to do that. So hopefully what you can do is create a directory in your Scratch area. You can copy that first login.txt file into that directory, then copy it from Dcache onto DevNull on the interactive node, and then remove the directory and then create a different one because we're going to copy a data file into it. So if everybody would like to try that, we'll give you some time. And I'm definitely going to run over.
I'll make up the time. Don't
Okay.
worry.
Great.
Use your time.
So first, does anybody have any questions on the assignment? Awesome.
No, I'm just exited and status null from the XRDCP. Well, that's probably copy it over. No. The problem is I copied it over a graph, so.
Maybe Control C it and then type it in again. Well, you know. So, you know, do you mind if there's somebody who has a question? You have mentors, yes, mentors, and mentees. I did this last night. Yeah, I thought I issued these commands last night on my laptop, but
Oh, now it works, okay.
yeah.
Something wrong with my setup. Obviously, there's some DUNE qualifier. I was setting up something with a DUNE qualifier and apparently it was doing bad things. So that may be a problem, but I'll learn it. It's pretty fancy. Boy, that dev/null is fast.
Yeah, dev/null is super quick. I think it's just Fermilab. Yeah, I apologize that this should work on LX Plus, except for the one problem with the KX509 and the proxy generation.
Yeah.
I don't know off the top of my
So-
head the parameters that we need to give it in
So
order to
there-
get that.
So
So
there's two issues, and they actually put it into the live doc, what to do. So the problem is if you are logged into CERN, your KX509 only works with Fermilab principal, so you have to destroy your CERN credential and get your Fermilab one, and then KX509 will work. But only if you have a
yeah, so we need to figure out a way to generate a proxy for someone who does not have Fermilab credentials, but does have CERN credentials. And I apologize that I don't have that off the top of my head. Sorry.
So we're.
They have to be DUNE members too.
Right, but the point is that we do have files here that you can read, so you can still do the announcements part even if you don't have a proxy for the purposes of this tutorial.
Yeah, and we should modify that. So-
Yeah. Okay.
Oh, okay, great.
No, I can see the answer.
Yeah, so because at some point I realized I didn't know how to have a click a button and reveal the answers, I just put the answers in here because quite honestly, having the answers is almost as educational as having to come up with it on your own.
I gotta say, the -D would get most people.
The -D is a really sneaky thing. So again, if your destination is a directory, you need to put the -D on there. So if you have multiple input files that you want to copy and the destination is a directory, for ifdh cp command, you have to put the -D. The number of times it's caught me out. So if you look, if you look right here, this is what I'm talking about. So.
Yeah, the good news is you have to put, the bad news is you have to put up with this this access method. And the good news is you have one heck of a lot of storage you can use.
Yep. So there is, and I believe also the resource. If you click right here, this will actually. I'll just do it. Show you, and you need a Fermilab sign in. Which okay, hold on, just a sec. So yeah. We should, if this is, what is this on? This is on
Redmine.
the Redmine. Oh, Redmine doesn't have SSO for CERN yet, does it?
No, I don't think so. And
Okay.
probably never will get it.
Yeah, because Redmine's a dying thing, but okay. I'll go back. Normally on this is one of those times where the virtual environment, it was really great. We could ask everybody to raise your hand when you or like clap when you were done or smile or something. And then it was a little bit more anonymous as opposed to holding up your hand or not holding up your hand.
Just look in the IFDS scripts to its users and see if their file is there. Right?
Sure, why not? I mean, they do delete it, but
Actually, by the way, I think you have write access to other people's user areas too.
No, no, you
Oh,
shouldn't.
you don't.
Well, at least not.
Yeah.
By default.
I do, but most other people don't.
Sorry? Okay. Oh, I'm sorry.
Yeah, no, I mean, the connection level went through, but then when I tried to do the CP, that it won't.
Did you set up
Yeah, I did all that. Oh, wait, so it's the CP?
No, no. Yeah.
set up IFTC?
Oh, it's just an example and I'm not having to do that anymore.
Okay, we're gonna. Do we have any questions from the people out in chat?
Yeah, are there any questions? If you're remote, raise your hand or give some symbol online if there was a live doc or a chat question. I apologize, I haven't been able to keep up with those.
Actually, I'm not seeing any questions in the chat.
Okay,
I'm watching a lot of live doc. I'm watching live doc.
thank you. So should we move forward?
Pushing time limit.
Yeah, we're pushing the time limit. Okay, so
I'm trying to do a 2-day tutorial in 3 hours. So.
yeah. So I'm going to move real quick. The next thing that we're going to talk about is XRT. XRT is your friend. It is not all powerful. It is not perfect, but man, it's really nice. So it is the extended root daemon. It's a software framework designed for accessing data from various architectures and in a completely scalable way. So as I talked about before, you can have 10,000 grid jobs come and connect to a storage element and read a bunch of root files or data files in general. And that storage element is not going to overload and melt down and fall apart, kind of the way that I would if 1,000 people asked me questions. So please don't all ask me questions at the same time. One of the things that is happening inside of IFTH is it's actually taking advantage of XRT to do a bunch of things for you. At the same time, you can, in fact, do bare exroot D commands. They're they're really safe if you know what you're doing. And it will give you the option of doing an ls, a make directory, a remove files, or things like that. But in general, we wanted to pull back and so that you have a little bit better understanding of what's going on. Exroot D works great because it does a number of different things. It can copy a file directly, but then it can also stream a file, meaning that if you run a program that processes event 1 through 100, what ends up happening is that root goes out and asks exroot D, please give me the first event, and it only sends the first event. You then run your algorithm over that first event, and then it goes back and gets the second event, and then the third event. And it's not exactly that way because there are chunks. But in general, that's the idea that you want to think about, that it's a live stream, that you don't have to wait to copy the entire thing. You can literally access it in small chunks, minimizing your bandwidth while you're using CPU to actually do the algorithm. So in general, this is pseudocode. You can do lar, which is the larsoft command. You give it the input file, you give it a URI, which looks something like a URL, but a little bit different, and then an input fickle configuration file. And larsoft will then talk, streaming the file and do the processing of that. Inside the code, this is what it looks like. So if you're familiar with opening .root files in general, you can also just put an exroot D URI in there in quotes. Boom. It'll treat it just like it is effectively a file that's being accessed kind of locally, and it does all the work behind the scenes to actually stream it live. So, let's practice. There is a great facility within IFTH that says locate a file. What it does is it goes and it talks to the data management system and says, please give me an exroot D URI so that I know how to access this, streaming it across the network. And in general, it is just IFTH, locate file, the name of the file, and then you specify root, because there are couple of different protocols that you could use, but we just want you to stick with root right now because, well, that's the best way to access everything. If you want SRM or grid FTP access things, you already know too much. Don't do that. The next thing we want to do is to try an exroot DCP, that file into the directory that you created in the previous exercise, and then use exroot DFS and the LS option, count the number of files that are in the same directory as this file. This will tell you how many files are in that directory and kind of how big is that data sample if you wanted to process all of them. So.
Special Unix tip, never put more than about 1,000 files in any single directory, or you will be very, very, very sad.
Yeah. And as everyone has seen, there are the solutions. Okay, so I'm 10 minutes over. So has anybody already done the locate file command? So what's the strange thing that you notice about the response that you get at the command line? Is there anything interesting that you notice? Yes, thank you. And you win a prize. I don't know what the prize is yet. There are two different locations. the fun thing is that we actually have our data replicated multiple places. And if you look, one of them happens to be located at Fermilab and one of them happens to be located in the UK. So the system should automatically direct, when you're using the full data management and data delivery services, direct you to the closest location. But right now, if you're given the option and you were here at CERN and you wanted to stream this file, which one would you choose? The what? Yeah, I would use the UK one and expect it to be faster response.
He will shoot you.
Well, it's Raul. Raul might get upset, but you know, I don't know why. I don't know why they would get upset. They want us to use these. And what we don't want to be doing is we don't want to be streaming files across the Atlantic Ocean or the Pacific Ocean, you know, or the Indian Ocean. If you can stream files across the Arctic Ocean, I am impressed because that cable doesn't exist, I don't think. Anyways, so yeah. The next command is an extra DCP command. Again, I am opening things. I'm kind of pulling back the curtain a little bit. You could also do this with IFDH CP, and it would work with the same, the exact same parameters. It would take care of it, but I just wanted to show you that it is possible to use these extra D commands directly. If you wanted a little bit more flexibility and dig in, IFDH does a whole lot of this for you and a lot more. This is what's going on in the background. So, and I think I'm going to skip the DF command. DF command, an exercise that is left to the reader. So I got another question for everybody. The destination for this file right here, in general, the terms that we've used for Dcache storage, what type of storage is this going to? Anybody? Oh, I mean, it's
going to Scratch.
It's going to Scratch, grid accessible Scratch storage. Why would I have 40 people copy one file to a Scratch space?
Yeah, what kind of animal are you?
And why would I not have them copy it to persistent Scratch space? Because no one's actually going to read this file. None of you are going to read this file, but 30 days from now, the LRU policy is going to delete it. And nobody has to think about it. Nobody has to go back and clean up. So I chose that volume specifically because I know I'm not going to remember it. The last time I did this tutorial, I didn't clean up afterwards, right? I can use Scratch space like that and know that it will get cleaned up and I won't be necessarily responsible for cleaning up and then allowing other people to use that volume later on. And the persistent volume, there would have been about 80 gigabytes of data that would have been used unnecessarily and never gotten cleaned up if I had had everybody copy it to persistent space. So when you were thinking about where you're going to put output, only put stuff into persistent if you know you are going to keep track of it, if you know that you are going to clean it up when you are done using it. If you got stuff that you're unsure about, put that into Scratch space. Once you figured out, yeah, man, I love these files. This is what my dissertation is going to be based upon. At that point, move it to more permanent storage, either on persistent or even better on tape back archive. I haven't shown you the tools to do that just yet in a really nice, coherent way, but I want you to be thinking about that so that 6 months from now, when you're doing an analysis that's going into the TDR or is going into a paper based on proto-DUNE data, you want to be thinking about the n-tuples that I've generated, the production files that I'm processing, where do I want them to be so that I know that I can reproduce my data, or so that it was just a test run, I don't want to have to clean this up and it'll get cleaned up for me automatically. Also, bonus points if you get automatically in your thesis. At that, I think I'm going to hand things over. Does anybody need any help? Because I'm going to hand things over to Steve and I can move around and help people out, answer questions. And again, apologies to those that only have CERN accounts. Sorry about that. I feel bad.
It's good to learn these things. Because we need to- It's good to learn these things. We need to get that fixed. So if people do have trouble, especially if you're working from CERN, get in contact with us because we will try to get them fixed.